In this lesson, we will study power supply module, module number 1. As you know from the last lesson, using a USB cable, you can only transfer data to Arduino, and without additional power, you won't be able to turn it on and program it. So, you need to supply power from another voltage source. There are several options for powering of Arduino. The easiest way is to connect an external power supply to the power socket on the Arduino module itself, which is located next to the USB. In this case, the voltage of the external power supply is recommended from 7 volt to 15 volt. This method of powering Arduino is only suitable if you turn on the Arduino module itself and also some other low power modules, such as LEDs or buttons. However, with this method, if you connect modules with high consumption to Arduino, then this module will require more energy through Arduino, and then some components on Arduino may fail. For this reason, both Arduino and the modules are powered separately from a powerful power source that can withstand heavy loads. Such a power supply is available on the IoT board itself as a separate module, module number 1. Module number 1 is a power supply module with which we can convert and stabilize different voltage values. We can visually divide this module into two areas: input area and output area. In the input area, there are power sockets for connecting different types of plugs. There is a DC005, such as Arduino. There is a thinner DC002. Between them, there is a switch to select the plug. If you have an external power supply with a DC005 plug, then the switch must be pressed to the side of this plug. On the left, there is a contact socket CON1. It is also in the input area in case users do not have a power supply with the right plug, but only a bare wire. In this case, poles are indicated next to the connector for convenience. In all connection options, a voltage of 9 volts to 15 volts is recommended. In the center is a green board. This is a cycle converter. It lowers the applied voltage to the desired level. In our case, it lowers the voltage from 12 volts to 6.7 volts. But with the help of the installed regulator, it is possible to change the output voltage at your discretion. This voltage is applied to the output contacts in the output zone, namely on the CON2 connector and the VOUT pins. It is not recommended to change the output voltage of 6.7 volts, since for the operation of linear stabilizers that are installed nearby, at least 6.5 volts are required. And if the voltage is too high, then these stabilizers will overheat and may break down. Therefore, the adjustment should be carried out very carefully and without the load turned on. That is, no other module should be turned on at the time of adjusting the output voltage. Linear voltage stabilizers are also installed on the module. One of the installed linear voltage regulators outputs a stable 5 volts, and the other 3.3 volts. These output contacts are labeled accordingly. It is from these pins that we can power other modules with the necessary voltages. And for convenience, the same output contacts were duplicated at several points on the IoT board, modules number 22 and number 36. Therefore, when you need to use the module, it is not necessary to pull a long wire through the entire work area. You can simply take power from the nearest point. Next to the power supply and its other points, there are copies of the power block from Arduino, modules number 8 and number 36, in case you need power from the Arduino. The module also has a switch and a power on indicator. Fuses and diodes are installed next to the stabilizers as protection against polarity reversal. For this reason, the output voltage of 5 volts and 3.3 volts can be reduced and distorted. In this form, the power supply module from one input voltage creates different output voltages for different modules. From 12 volts comes out 6.5 volts, 3.3 volts, and 5 volts. Let's now move on to practice. Connect the external power supply to the power socket. If you have a DC002 plug, then after connecting to the corresponding power socket, you need to move the switch knob towards this socket. The CON1 connector also works in the same switch state if you need to connect external power using ordinary bare wires without plugs. But in our case, the power supply has a DC005 plug, and we need to connect to the socket to the right of the switch, as indicated here. Don't forget to switch the knob to select the power. Now, pay attention to the button. With the help of the button, we turn on or off any of the selected power inputs. The on state is indicated by LED L1. After switching on, the LED will light up. To work with the module, first of all, we need to adjust the output voltage on all contacts. This calibration is done only once when you turn on a new IoT board. For that, we will need external power supply, multimeter, and a thin screwdriver for adjustment. Step 1. Check that the module is on and the LED is on. Disconnect all other wires if connected. Step 2. Turn on the multimeter and set it to DC voltage measurement mode. In our case, we move the dial to 20 in the DCV section. That is a constant voltage of up to 20 volts. Connect the cables with probes as indicated. That is, the red cable to the multimeter contact where there is a volt and omega sign. The black cable must be connected to the COM terminal. In this state, the multimeter measures DC voltage. Step 3. Now measure the output voltage at the COM2 pins on the power supply module. For that, put the probes on the metal pins of the connector. Be careful, the output contacts must not touch each other through the metal probes of the multimeter. Otherwise, a short circuit will occur and the module components may fail. On the screen of the multimeter, you will see the voltage value. The voltage at the output of CON1 should be 6.7 volts. If your values are displayed with a minus sign, just rearrange the probes. Step 4. If it shows a different value, you can adjust it to any voltage you need. For that, take a screwdriver and very slowly begin to rotate the adjuster on the cycle converter. Always pay attention to the screen of your multimeter. On the CON2 pins, values from 6.5 volts to 7 volts are recommended, particularly 6.6 volts. The VOUT contact installed nearby is a follower of CON2 and should give exactly the same value. This is for convenience. Step 5. In the same way, you can measure the voltage at the output pins 3.3 volts and 5 volts. The values on these pins can be lowered on purpose, and you will not be able to adjust them. But this will not interfere with our work. This completes the calibration. Now, to transmit voltage to other modules, you just need to connect the power supply pins of the module to the output pins of module number 1. For example, to turn on Arduino, you need to receive power from the VOUT pins. For that, connect the pins as follows. VOUT plus, connect to Arduino pin VIN. VOUT minus, connect to the Arduino pin GND. At the moment of connecting the wires, the module itself must be turned off. After connecting, turn on the power supply module. We see that the power indicator of the Arduino module also lights up. Since the power block of the Arduino module has been duplicated next to the power supply module, you can use shorter wires for connections. Everything works exactly the same. Now, let's try to turn on module number 2. For that, first disconnect all the wires from the previous example. Be careful. To work with other modules, you need 5 volts and not 6.6 volts. Therefore, we will connect to the output contact 5 volts. Connect the pins as follows. Connect plus 5 volts to plus pin of module number 2. G&D connect with the G&D pin of module number 2. At the moment of connecting the wires, the module itself must be turned off. After connecting, turn on the power supply module. We see that the power indicator of module number 2 also lit up. We will look at this module in more detail in the next lessons. Everything is working. Congratulations! You have learned all the basics of the power supply module.